So, good morning. I have made some progress with the new hardware, and first I want to show you the new phase modules. So, I hope the camera will focus. So here you see the gate driver chips, and the high side is just supplied by bootstrap topology. And on the top you can see the DC bus that just consists of brass standoffs, and on the bottom we see the, well, right now very rigged up AC bus that also connects via short standoffs right next to the IGBTs. And this can be populated with 160 amp IGBTs and would then be capable of 320 amps and 400 volt. These are 1200 volt parts because for my high voltage conversion, but 1200 volt parts don't exist in such high current ratings. I only found some up to 75 amps in this package. So, and you can see if you were to use multiple sets of modules, how you would just extend the AC bus to parallel them. Same goes for the DC bus. So basically you extend one polarity and just would have a bus on this side for one polarity, and then extend this one, it isn't right now, and have a bus for the other polarity to connect them DC wise. And then something you can see here is a Melexis chip. It's a current sensor, and it senses the current as it runs over it, and it replaces the Hall effect. Well, it is the Hall effect, but it replaces the through-hole current sensors that I used to supply and that are big and expensive. So yes, that's the state of the new power stage. Then here we have, I fixed it. Anyway, you can see how there is a board extending up from the main board, and that's the Isolator board. And it's soldered right into the main board. No cable connection there. And this is what it looks like. So it has a DC-DC converter and can be populated with up to 6 watt parts. This is just the 2 watt parts because it's small IGBTs, they don't need much power to be switched. Then there's a 6-channel digital isolator which transmits the gate signals. Then this unpopulated part would be a regular photocoupler that can transmit an arrow feedback signal back onto the primary side. And then here we have an analog isolator like Damien uses that transmits the DC bus voltage onto the primary side. And also the temperature sensor now connects to this board, and that makes the entire former sensor board redundant. And last but not least, we have this filter board right here. The inverter is capable of running as a boost or buck mode charger. So basically you go in here with your AC line voltage, and it's being first order filtered by this inductor and capacitor, and then there's a stop band filter that is tuned to the PWM frequency that sucks in even more PWM spikes. And I haven't really measured on grid, but I have set up a grid simulation in LT Spice, and the frequencies that kind of are fed back into the grid. The levels are below what is required by law. Yes, so then yeah, we get the rectified output on that side, and it's fed to the bridge for the charging. So yeah, is that it? Maybe just a word on the size of this whole package. This is about 180 millimeters long, from the last capacitor to the IGBTs. So it fits on a 200 millimeter heatsink, and this is, I think, 240 wide. And I'm even wasting a lot of space by having, for example, this slide down. It can also be mounted somehow, standing up, you know. But anyway, it's already a pretty small package, I think. So the casing concept will be a base plate like that, screwed onto here and here, and all the connections will be made on this side. The motor will bolt on these AC outlets. The DC bus can be connected here and here, also cables coming in here. The AC input will also go right over there, and the control inputs would come out from the super seal connector that I might use. I haven't really understood the concept because it doesn't have any screw holes to use. Yeah, anyway, but it's pretty small for what it does, so I'd fancy using it. Right, and then when the base plates are installed, a U-folded sheet metal will just be screwed on and tightened by rubber seals, and that should do the trick. The AC bus bars will also be used with some isolating material to actually hold this in place, and then there will be some heat conducting material to actually connect the IGBTs to the heatsink. Yeah, that's the plan, and when that's done I will shoot another video and let you know. In 2 weeks time it's supposed to go into my own conversion. See how that goes. Thanks for watching.